Assalamu alaikum, brothers and sisters. Welcome to the journey of quest, where we quench your thirst of knowledge. Have you ever wondered how the minerals buried deep beneath our feet influence our daily lives? Well, they do, and in ways more profound than you might imagine. Minerals are not just mere rocks. They have a story to tell, a role to play, and properties that make them invaluable. Understanding minerals and their properties is like unlocking the secrets of the earth itself. It's a journey of discovery where each mineral presents a new chapter full of surprises. Today we're going to explore three intriguing characteristics of minerals: their electrical, magnetic, and optical properties. From the spark of electricity that lights up our homes to the magnetic force that guides our compasses, from the breathtaking colors of gemstones to the invisible waves that carry our internet signals, minerals are at the heart of it all. Now that we have whetted your appetite, let's delve deeper into these fascinating properties. Imagine a world without electricity. Hard, isn't it? Did you know that some minerals are key conductors of electricity? Let's delve into the fascinating world of minerals and their relationship with electricity. The electrical properties of minerals such as conductivity, resistivity, and piezoelectricity play a pivotal role in their utility and function. Conductivity, the first property we'll explore, is the ability of a mineral to allow the flow of electric current. Take silver, for instance. It's the champion of electrical conductivity among minerals. This attribute makes silver highly sought after in various industries, particularly in electronics. Silver's atomic structure allows it to easily pass along electric charges, making it a superstar in the world of conductive minerals. On the flip side, we have resistivity, which is essentially the opposite of conductivity. This property measures how much a mineral resists the flow of electricity. Perfect conductors don't exist in nature, and every mineral will resist electricity to some degree. The higher the resistivity, the poorer the conductor. So while silver is an excellent conductor, minerals like quartz or diamond have high resistivity, meaning they're not so great at passing along an electric current. But don't write off quartz just yet. It has a unique electrical property of its own: piezoelectricity. Piezoelectricity is the ability of certain materials to generate an electric charge in response to applied mechanical stress. If you squeeze a piezoelectric mineral like quartz, it will generate a tiny electric charge. This property is exploited in a variety of applications, from the humble gas lighter to sophisticated ultrasound machines. Understanding the electrical properties of minerals allows us to harness their potential in countless ways, from powering our gadgets to enabling scientific research. The world of minerals and their interplay with electricity is a testament to the incredible complexity and diversity of our natural world. So the next time you switch on a light, remember the minerals that make it possible. Did you know that not all minerals are magnetically attracted to your fridge door? Let's dive straight into the magnetic properties of minerals. These properties are fundamental in understanding the behavior of minerals in different magnetic fields. And they can be broadly categorized into three types: magnetism, paramagnetism, and diamagnetism. Let's start with magnetism. This is perhaps the most well-known of the three, thanks to a mineral we've all encountered at some point: magnetite. This mineral is naturally magnetic, which means it's capable of attracting iron. It's the most magnetic of all the naturally occurring minerals on Earth, and it's this property that led to the discovery of magnetism thousands of years ago. Next, we have paramagnetism. This is a form of magnetism whereby certain materials are attracted by an externally applied magnetic field and form internal induced magnetic fields in the direction of the applied magnetic field. A perfect example of a paramagnetic mineral is pyrrhotite. Now, pyrrhotite isn't as magnetic as magnetite, but it's still attracted to magnets. However, once the external magnetic field is removed, pyrrhotite loses its magnetism. It's a temporary thing, unlike magnetite's permanent magnetism. Lastly, we have diamagnetism. This is a very weak form of magnetism that is only exhibited in the presence of an external magnetic field. It is induced by a change in the orbital motion of electrons due to the external magnetic field. The effect is so weak, it's often hard to detect. This property is found in minerals such as graphite and diamond. The magnetic properties of minerals are more than just a scientific curiosity. They play a vital role in technology, industry, and even our daily lives. From compass needles to MRI machines, the magnetic properties of minerals have far-reaching applications. So while your fridge magnets are fun, the magnetic properties of minerals are truly mind-blowing. Ever wondered why some minerals sparkle while others do not? It's not magic, but rather a fascinating aspect of geology known as optical properties. These properties are what make minerals visually distinct and intriguing. Let's delve into the heart of the matter. One of the most noticeable optical properties is color. Minerals come in a rainbow of hues, from the deep blue of azurite to the fiery red of cinnabar. But what gives them these colors? Well, it's largely down to the presence of specific elements and compounds within the mineral structure. For instance, the iconic green of an emerald is due to the presence of chromium and vanadium. Next up is luster, which describes how light interacts with the surface of a mineral. Some minerals, like gold, have a metallic luster reflecting light like a mirror. Others, like quartz, exhibit a vitreous or glassy luster, while yet others might be described as pearly, silky, or even greasy. Luster is a key factor in the sparkle we often associate with certain minerals. Finally, let's talk about refractive index, a measure of how much a ray of light is bent or refracted when it enters a mineral. A high refractive index means greater bending of light, which can result in spectacular displays of brilliance. Diamond is a perfect example of this, boasting one of the highest refractive indices in the natural world. All these properties, from the color to the luster to the refractive index, combine to give each mineral its unique appearance. They dictate whether a mineral will be transparent or opaque, shiny or dull, brilliant or subdued. Remember, these aren't just abstract concepts. They have real-world implications, from gemstone grading and identification to the exploration of mineral resources. So, the next time you admire a shiny mineral, remember the optical properties that make it so captivating. So, we've journeyed through the world of minerals, discovering how they influence our lives in ways we may not have realized. Let's take a moment to reflect on what we've learned. We started with the electrical properties of minerals. Remember how minerals like copper and silver are electrical conductors? They allow electricity to flow through them, making them indispensable for wiring, circuits, and all sorts of electronic devices that we use daily. And then there are minerals like quartz and tourmaline, with their fascinating piezoelectric properties. When pressure is applied, they generate an electrical charge, a phenomenon that's harnessed in items like watches and microphones. Next, we delved into the magnetic properties of minerals. Iron, nickel, cobalt. These are magnetic minerals drawn towards a magnet. They're the reason why compass needles point north, helping us navigate the world around us. But they also have more advanced applications, like in computer hard drives, where they store the data that fuels our digital age. Finally, we explored the optical properties of minerals. We talked about how minerals like diamond and calcite refract and reflect light in unique ways, creating beautiful displays of color and brilliance. These properties are not just aesthetically pleasing, they are also scientifically significant, used in optics and laser technology, and even in determining the mineral's identity. So you see, minerals are more than just pretty rocks. They are the building blocks of our modern world, with properties that make everything from electronics to navigation, data storage, and light technology possible. As we go about our day, let's not forget the silent yet significant role these minerals play in our lives. They are in the ground beneath us, in the devices we use, in the data we store, and in the light that sparkles in our eyes. Remember, the world beneath our feet is more than just dirt and rocks. It's a treasure trove of minerals with properties that power our world in the most extraordinary ways. Minerals, as we've discovered, are not just for geologists or confined to our science textbooks. They are a fundamental part of our everyday lives. Let's take a closer look. Remember the piezoelectric property of quartz that generates an electrical charge when pressure is applied? This very phenomenon is harnessed in our wristwatches, keeping us punctual. And don't forget copper, the electrical conductor. It's in the wires that power our homes and the circuits that make our devices work. But the story of minerals doesn't end with electronics. They're also essential in construction. Gypsum, for instance, forms the core of our drywall, giving our walls and ceilings their structure. Limestone, on the other hand, is a key ingredient in cement, the binding agent that holds our buildings together. And have you ever wondered what gives your cosmetics that shimmer, or your face mask its purifying properties? It's minerals again. Mica is what adds that sparkle to your eyeshadow and highlighter, while kaolin, a type of clay, is often used in face masks for its absorbent properties. So the next time you check the time on your watch, switch on a light, apply your makeup, or even take refuge in the comfort of your home, remember the silent yet significant role minerals play in making it all possible. They're not just beneath our feet, but also in the devices we use, the buildings we inhabit, and the products we apply. It's the power of minerals quietly shaping our everyday world. As we look to the future, the role of minerals becomes even more crucial. We've seen how they're embedded in our everyday lives, but their potential stretches far beyond our daily routines. Let's delve into the exciting world of tomorrow, where minerals promise to play an even bigger part. Consider renewable energy, a field that's rapidly gaining momentum as we strive to combat climate change. The batteries that store energy for our electric vehicles and solar power systems, they wouldn't exist without lithium, a lightweight mineral with a high energy density. And speaking of solar power, those shiny solar panels that convert sunlight into electricity owe their existence to silicon, the second most abundant element in the Earth's crust. But minerals aren't just powering our homes and cars, they're also propelling us into space. Iron, one of the most common elements on Earth, is a primary component of spacecraft. And then there's helium-3, a non-radioactive isotope that's rare on Earth but abundant on the Moon. Some scientists believe it could be the key to clean fusion-based energy in the future. Even in medicine, minerals are making waves, gold nanoparticles are being used in diagnostics and drug delivery systems, while calcium, a mineral we often associate with healthy bones and teeth, is a crucial ingredient in many pharmaceuticals. So whether it's powering our green revolution, taking us to the stars, or pushing the boundaries of medicine, minerals are at the forefront. The future of minerals is as bright as a diamond, promising to illuminate new paths for humanity. As we continue to unravel their mysteries and harness their powers, there's no telling what amazing discoveries await us. So, stay curious, stay excited, and remember to appreciate the silent, yet significant role of minerals in our world. In the words of a wise comic book character, with great power comes great responsibility. As we marvel at the incredible potential of minerals, it's important to remember that these resources are finite. We can't keep extracting minerals from the Earth without considering the environmental impact. That's why sustainable mining practices are becoming increasingly important. These involve methods that reduce waste, use water more efficiently, and rehabilitate mining sites after extraction. But conservation doesn't stop at the mine. We can also recycle and reuse minerals. Old electronics, for instance, are a treasure trove of valuable minerals like gold, silver, and copper. Instead of discarding these devices, we can recover and reuse these minerals. Similarly, construction and demolition waste often contains materials like concrete, brick, and asphalt that can be recycled into new building materials. By doing so, we not only save resources, but also reduce the amount of waste that ends up in landfills. So, as we look to a future powered by minerals, let's also remember to treasure these resources and use them wisely. After all, our actions today will shape the world of tomorrow. Thanks for watching us share our videos, subscribe our YouTube channel, and press the bell icon, and stay curious for new uploads.